My name is V Dinesh, and the topic is applications of discrete random variables, and the subject is probability and statistics. Discrete random variable. In an experiment, a person may be chosen at random, and one random variable may be the person's height. Mathematically, the random variable is interpreted as a function which maps the person to a person's height. Associated with the random variable is a probability distribution that allows the computation of the probability that the height is in any subset of possible values, such as the probability that the height is between 180 and 190 centimeter, or the probability that the height is either less than 150 or more than 200 centimeter. Another random variable may be person's number of children. This is a discrete random variable with non-negative integer values. It allows the computation of probabilities for individual integer values. The probability mass function or for a set of values including infinite sets. For example, the event of interest may be an even number of children. For both finite and infinite event sets, the probabilities can be found by adding up the PMF's probability mass functions of the element, that is, the probability of an even number of children is the infinite sum. PMF of 0 plus PMF of 2 plus PMF of 4, that is even numbers probability mass functions summation up to infinite. In examples such as these, the sample space is often suppressed since it is mathematically hard to describe, and the possible values of the random variables are then treated as a sample space. The set of all order pairs of x, f of x is a probability function, and also called a probability mass function of the random variable x. If for each possible outcome, and the properties are if f of x is greater than 0, greater than or equal to 0, summation of p of x is equal to summation of f of x is equal to 1. The sum of all possible probability values of x must be equal to 1, and f of x lies between 0 to 1. All probability values of x must be between 0 and 1. The probability the random variable x takes on a particular value x. For example, let's determine if the following probability distributions are discrete probability distribution. In the first table, in the first table, summation of f of x is equal to 1. It follows discrete random variable property, and and the second table given summation of p of x is not equal to 1. It is greater than 1, so it is not a discrete probability function. And third table, summation of f of x is negative, so this is also not discrete probability distribution, because from from the properties of discrete random variable, from the second point we can from the first and second and third point we can know that the sum f of x is greater than 0, greater than or equal to 0, and sum of all possible probability values of x must equal to 1, and all probability values of x must be between 0 and 1. Applications of discrete random variable. Applications in civil engineering. If we want to find load on a specific point in a beam, we can use discrete functions to find loading at each point on a beam. Suppose a loading on a long thin beam places mass only at discrete points. The loading can be described by a function that specifies the mass at each of the discrete points. Similarly, for a discrete random variable x, its distribution can be described by a function that specifies the probability at each of the possible discrete values for x. Application 1. Statisticians use sampling plans to either accept or reject batches or lots of construction material. Suppose one of the plans involves sampling independently 10 items from a lot of 100 items in which 12 are defective. Applications in electrical engineering. If you want to find probability of circuits accepted or not, application 1. If number of given integrated circuit would be accepted or rejected, we use discrete probability mass function. Application 2. If you want to find number of semiconductor wafers that need to be analyzed in order to detect a large particle of contamination in p-type or n-type material or in doping material, we use random variables or discrete random variable. And application 3, if we have number of circuit and we need the probability to test circuit to be defective and non-defective, we use discrete variable distribution to find the number of defective and non-defective circuits. And application 4 is for quality control, x is equal to the number of steps examined before the first faulty one found. X, f of x, x of f x of f means probability of faulty equal to 1, probability of safe, and another one is faulty equal to 2. Probability of third is safe and faulty equal to 3. Probability of safe and faulty equal to 4, and so on up to probability of safe, faulty equal to 8, etc. And applications in business. Application 1. In any business firm, there is a communication system with certain number of lines to communicate data and mass communication. If we need to know the probability of how many lines are working at one time, we use discrete variables. Other applications. Number of airplanes taking off and landing during a given time in an airport. There are two PIA flights landing from Islamabad Airport to King Abdul Aziz Airport at Jeddah, and two PIA flights departing from King Abdul Aziz Airport at Jeddah every day. So 2 is a discrete number and can be denoted as X discrete random variable. And that's it. Thank you everyone.